Hello everyone. Let's solve this LeetCode problem +1. This problem. Okay, so let's start and let's try to understand this problem clearly. So as the question defines, so it gives an array as an input. तो आपको एक array मिलता है as input, and what we can do, we need to do +1 to the array. So if the last digit is less than 9, so it is just an addition of 1, so it becomes 1 to 4, and the length of the array is remain constant. But assume in this example 3, if the digit is 9 it becomes 10, so the array size has been modified, so we need to update the size of the array. So in this case, so it could be a malloc function we need to update. Okay, let's give an attempt on that. Okay, so in this function it defines where I am trying in C program. So the attempt is using, and the function is provided, return type is in integer pointer, and the three parameters are given: integer pointer, array, pointer to the array, and then size of the array, and then the return size, what is the updated size you are returning. So these three things are the provided input, and let's try start 1 to LSB. So LSB in this case, assume the array is 1 2 1 4. 4 is LSB and 1 is the MSB. So let's add 1 to this part. Okay. So for that, let's take this array, digits is the array, and then provide the size. Who will type it to provide it, right? Okay, let me copy. If something of the naming convention gone wrong, then again it will be a problem, right? So we'll get care on this. Okay, digit size, digit size is greater than always one more than the actual value, because the value count starts from 0 in an array in C. Let me make it -1. Okay, and then what is the value? We need to +1, so let me make it +1. Okay, so let's go for an iteration. After that we'll modify. Why I'm not making it live? Probably I'll plan it someday to live it, like coding. LeetCode. That could be better. Yeah, yeah. Let's do it now for that. Okay. So let's try for loop. I'll iterate from the end to the beginning. So let the I is equal to the digit size -1. I am new to Mac, so this sometimes the key is, I don't know what it is doing. Okay, so I initialized with I equal to digit size -1, then I is greater than equal to 0. Okay, then let's decrement I minus minus. Okay, is it good? Okay, so from the end greater than 0, greater than equal to 0 till 0 to come until going minus. Okay, so if the digits of I is greater than 9, so what is the plan is that right now is, so assume the digit is like this 1 to 9, and we are doing this +1, right? So it will becomes 1 2 and then 10. Okay, 10 is also an integer, so it can be stored. So we are checking first if the digits after, so digits array of size of position I, that is the end position, is greater than 9, then we'll do our operations. Else if it is not, then we don't know to, that's just a return. So what we can do, we can just return like, you can just update digits with I minus 1. No, if it is okay, sorry, if it is not, then probably we'll just return. So what will return, so we'll return size, return size, is the naming same? Yep, return size is equal to the digit size, so there is no change in the length of the array, so it is same. And array also we need to return, so return digits, so it is the same array, we need to return, that's all. So it is okay. So this is our main algorithm. Main algorithm. Okay. So basically we'll check for 9 or carry forward digits. Okay. 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 So now, okay, I just make it some notes to understand. Okay. So now we know that that position is greater than 9. So what we do, if it is greater than 9, so it is 10. 10 means we need to keep an 0 on that position. So let's allocate 0 digits of I equal to 0. That position we defined with 0. Okay. So if I equal to 0, if it is the MSB part, basically if it is the most significant bit, else it's not the most significant, propagate to the, okay. So else, just to you guys to understand this one, else part, let me keep it like this. If it is 0, then the previous part should be increased, so I just keeps increasing it, digits I minus 1 plus equal to 1. Okay, digits I minus 1, the previous bit has been increased, that means this example it becomes 0 and the previous bit position is 2, it becomes 3. Okay, so uh, okay, got it. So then it will come back to this array. If it checks digit I is greater than 9, no, then we just return it. So assume this also, this position is also 9. Okay, this is also 9. So in that case what happens, it will return 10, correct? It will return 10. 10 is greater than 9. So in that case what will happen, it will also go to 0 and then make it 2. Do it. But in this case assume this is 9, then what it will become, it will become 10. So it is the LSB part, right? So this is what we are checking here. So this is the checking LSB part to increase array size. Okay, got it. So what we'll do, so what we'll do, in if we reach the LSB and we need to increase the size, then what is the problem, then we'll do the malloc, right? So integer pointer result. Okay, so basically we define a new array, or basically we create a new array using malloc function. So how to define, it is integer pointer, then malloc, then size of, so so size of the array is the same, right? So basically we need to define size of array, so it is equal digit size is defined as digits size plus 1, because we incremented this Okay, then into define the size of integers. Okay, if I do any typo, let me know or comment it down, guys. Okay, so the result of 0. So the zeroth position is always 1. Okay, because see, if it is incremented, so what will happen next? The increased array, it is always 1, right? Can become 0 0 0. So the length has been changed to 4. So new size is digit size plus 1, digit size is 3, so it becomes 4. And then we define the position as 1. So then what we'll do, we'll do a for loop and then allocate rest of things. Okay, let's define integer j equal to 1 first position, j less than size of digits plus 1. So j is less than digit size plus 1 and then j plus plus, correct? Okay, then just allocate the result array j, just assign with digits j minus 1. Okay, because we are allocating this, if when it is 1 we need to allocate 0, so in that case it will become j minus 1. Okay. So once this is assigned as 10, we need to return our result. Return pointer result is our new array, correct? So similarly also we need to update our array size, so digit size also has to be updated. So pointer return size is equal to digits size plus 1. Okay, and then also returns the results. Okay, then this else, what is it completed? This else is completed. And then if all goes good, just copy this and paste this. If nothing happens, this will. Okay, now you just return size is same. Let's update. Okay, let it be. Anyway, it is not going to reach this part of the code. Okay, just return the default. Yes, okay. That's okay. Okay. This is for loop, right? Sorry, guys. This is a for loop will end here, right? So this part will be the end. Okay, okay. So let's run for the first trial load. Let's see how is the result is coming. Something gone wrong. Okay, the naming was wrong. Let's see what's the result coming now. It's, sorry guys, the typo errors are going on. Okay, sorry, it is already a mistake. It is an already. Okay, so line 136, 31, 36 onward. So let's return digits. Okay, sorry guys. Yep, we have done it. It's accepted. Sorry for the delay, guys. So all the cases has been passed. So the mistake was only Okay, we don't need to return the size because it is only the same if there is no change in the array. So okay, the only problem here I made is basically I returned pointer type. It's already a pointer because it's a typo error. So it's fixed. So that's all. I think rest of the codes are what we discussed. So as for that, so you guys can try this out. So let's submit it. Let's see how the code behaves on the screen. Yeah, yeah, it's good. Runtime is 100% ahead of RC. So if you see this part, we have done good. It's with 100% of users with C code, and memory is 72%. We beat 507 MB and we can beat this much. So it's a good result. Okay. Yep, that's all. You guys can try this out. If any queries, let me know. Thanks. Bye.